NASA's Astrophoto Challenge lets you make your own space image using real astronomy data, this time featuring the Cassiopeia A supernova remnant. But before you get started, let's find out more about what we're seeing in these remarkable images. At first glance, Cassiopeia A, or Cass A for short, looks like a wispy circular nebula of colorful filaments. Over decades of study, astronomers have learned that it was formed from a supernova explosion.
Supernovas are caused by the collapse of massive stars under their own gravity, when the nuclear fusion that had previously fueled the star can no longer overcome the star's enormous gravity. A complicated implosion-explosion occurs, leaving behind either a neutron star or a black hole. These explosions are among the most powerful we know of in the universe.
A supernova remnant forms from supernova explosions, creating an expanding cloud of stellar debris and interstellar material, which is heated by the supernova blast wave. These remnants are among the most beautiful objects which is possible to observe in the night sky.
Radio astronomers first discovered Cass A in 1947, finding it to be one of the brightest radio sources in the sky. But now we can observe it across the spectrum of light.
Each color of light reveals unique clues about the supernova's composition, temperature, and movement, painting a full picture of these stellar explosions. Dominating Cass A is what we call the main shell. This is where the bulk of the gas from the exploded star is located.
The remnant is bounded by the shock wave from the explosion, propagating through the ambient environment. Within, we discern a highly uneven distribution of stellar material that was expelled from the explosion. Alongside a prominent jet-like feature near the center, a compact object is visible, the neutron star left behind by the explosion. Observations of Cass A also unveil emission from high-energy particles accelerated at the shock fronts, and in the optical and the infrared bands, we can also recognize background-foreground stars, which, however, are unrelated to the supernova remnant.
Supernova remnants reveal important things about the world around us and even ourselves. Many elements in the periodic table are forged primarily in supernova explosions.
Quoting Carl Sagan, "We are made of star stuff. The cosmos is within us. We are a way for the universe to know itself." This is absolutely the truth, because supernovae are incredible factories for the creation of elements essential for life on Earth.
The oxygen we breathe, the nitrogen in our DNA, and the carbon in our apple pies all come from supernova explosions.
These building blocks of life were forged billions of years ago inside the cores of stars and dispersed into space through supernova explosions.
As citizens of the universe, I think it terribly important that we understand this fundamental process that allows us to exist.
Each of the datasets you can use to build your own image comes from a different part of the spectrum, and each tells us a different part of the Cass A story.
X-ray traces hot gas. Optical light traces cooler, denser gas. Infrared light from the James Webb Space Telescope shows us some of the coolest gas and dust. And radio light traces movement of the powerful supernova shockwaves.
The structure of supernova remnants helps astronomers understand how massive stars live and ultimately die.
The Chandra image sensitive to iron is among the most interesting for people who model supernova explosions, because this is some of the heaviest elements that were produced closest to where the explosion originally took place.
James Webb observations revealed a puzzling mystery structure, which is the so-called green monster. This feature is made of circumstellar material and is characterized by ring-like features and holes. It is interesting that just 1 year before these observations, numerical simulations have predicted these features. And now we can use these models for the interpretation of James Webb observations.
In addition to these datasets, you can also request observations that will be scheduled and collected just for you using the ground-based Micro-Observatory Robotic Telescope Network. These images will cover a wider field of view, showing Cass A in its surrounding environment.
Recently, it was possible to identify features in Cass A that can be attributed to physical processes occurring within the first seconds after the collapse of the stellar core. I think it's amazing that today, 350 years after the explosion of the star, we can recognize the hallmarks of those events that took place deep within the star, marking the culmination of its life cycle.
Cass A is more than a supernova remnant. It's a vibrant canvas showcasing the universe's tremendous power and ability to create stars, planets, and life.
There are countless ways to mix and match these data sets, and we encourage you to submit your creations to the Astrophoto Challenge website. Your work might even be featured as a standout entry.
Now it's your turn. Try NASA's Astrophoto Challenge yourself.
We want to see the pictures you've made.
Tell us about the colors you have chosen.
Make sure to share your images with us and to tell us about your creative decisions.
Were your choices scientific, artistic, or both?